so if you have any questions along the way, please raise your hand, let me know. I just want to do my best to give you what you're looking for. So as was stated, I'm a landscape contractor. I actually started at Cal Poly in landscape architecture and quickly realized I was in the wrong place, so I transferred majors to ornamental horticulture. And although that did incorporate some design courses, my main focus was building gardens. So that's what I like to do, that's my passion. And also my passion is teaching, so that's definitely come out working here at QAMF College and then doing events like this. So again, pretty informal, so please, if I say something that you didn't understand or somebody told you something different, I would appreciate any feedback. There's a lot of professionals out there and there's a lot of ways to do things. One thing I've learned over all the years is that there's more than one right way, there's more than one way for sure. I just have what I do and what works for me, but that doesn't mean it's the same for everyone. So we're going to today talk about irrigation mulch, soils, and planting. It's a lot to cover. I'm not going to go super in depth to any area. I understand that you just finished some soils education, and so there may be questions that come up about that because maybe I'm presenting something differently, maybe it's the same, I don't know. But I think I commend all of you for what you're doing. I think it's amazing to spend all this time getting educated and then giving it away. It's a wonderful thing. Educating the public, I think, is so important. We all see it every day. I was just up at a landscape conference in LA, and as you know, we had the driest year in over 100 years. And what do I see as I'm walking from downtown LA to the convention center? Is they're washing down the sidewalks. Californians just haven't woken up yet. My guess is, and the sad thing is, the only way to get people's attention is that water rates have to go through the roof, and they eventually will. They've gone up a lot, as you all know, but not enough apparently to affect the general public. We've all seen it. You're driving down the road, you see sprinklers spraying in the street. It's tough. So we're going to start with water management. This is probably the most challenging part. Well, I guess we'll start with early in the morning while everybody's still awake. I often get these questions. How much should I water? How often? How deep? How can I tell if I'm over or under watering? And how many start times should I use? So the big answer here is it depends. And I have, as you know, I'm a landscape contractor. I have people call me up, never met them, spoke to them on the phone. How much does landscaping cost? Well, it depends. But it's that kind of question with water management. As we'll discuss today, it depends on so many factors. Soils, plants, where you live, the exposure, how mature the plants are, and it just, and then the type of irrigation system you have, the efficiency of that irrigation system. It's a tough one, and I know that you're going to have to answer these kind of questions, and hopefully I'll give you something to at least get started with. And generally what you're going to have to do is ask a lot of questions before you can honestly answer their questions. So required information. These are things that you're going to need to know. Is type of irrigation system. There's all types, and we'll go into that. The site location. I don't know if most of you are familiar, but if you live on the coast versus living in an area like this, it takes at least 50% more water to irrigate here the exact same landscape as it does on the coast. And that's just purely based on the exposure, on the elements, on the temperature, the humidity, the wind, and again, 50% is probably a conservative number. So knowing where your customer or the person that's asking the question lives is key. In addition to that, then there's microclimates. I live in Escondido, and I live in a microclimate. And how do I know this? Because in the morning, it's 49 degrees. I drive west to my office, which is more mild, right? I drive all the way to Vista, 10 miles away, and it's 41 degrees. It's 8 degrees cooler in Vista. It's because my office is in a low spot. Now that's another microclimate, because Vista is usually pretty mild. I have had a huge ficus tree that fell over the other day. We won't get into that. And we get a hard frost, not one leaf burned on it. I saw that and I got excited and I planted a mango tree. And it was very hard not to do it last year, but I did not cover it. I left it exposed during the winter, no damage whatsoever. And this is unheard of. You would say in Escondido, you cannot grow a mango tree without protecting it during the winter. Well, I live in a microclimate, so that's going to vary. So kind of understanding that. Soil type. So as you're all now perfect experts in soil sciences, you have your coarse soils, you have your fine soils. These have a huge impact on how long you're going to water. Because as you know, sandy soils can take water very quickly, and clay soils you take it only very slowly, or you're going to be wasting water. So that, and then this degree of slope. If it's very flat, it's more likely to be able to take the water in. If it's very steep, you're going to have to lower the watering times. Time of year, of course, in current weather. Today we have this gorgeous day. It's cool, but it's sunny, so that's going to use a certain amount of moisture. If it was really cloudy, it would be less. If it was windy and hot, it would use a lot more. So time of year or what's going on outside is going to really affect it. Exposure. Again, is it on the shady side of the house? How many hours of sunlight does it get? Is it under a tree? All of these things are going to affect the amount of irrigation your plants need. And then, of course, the plant type. Here, most of the plants on display are either drought tolerant and California natives. There's not too much else. There's a few examples of heavy water using plants. That all makes a very big difference. I think a great example of what happened in the last several years here, even though it was kind of sad to see the economy go downhill and see foreclosures, but one great example that you can all see is what happens when the water gets shut off. And how many people saw homes where sure the lawn died and the vines died and anything in a pot, but there were shrubs and trees that showed no effect of not being watered every day. In fact, some of them were happier. Like bougainvillea and some mature trees and shrubs. It just shows how much we overwater. That was a great example for you to realize, there hasn't been a spot of water on this garden except for the rain, that we don't get a lot of, and how a lot of the plant material was not stressed at all. And I think that's what people don't realize. They think they live in Southern California, you gotta water. So type of plants. Mediterranean plants, that's pretty self-explanatory. We live in a Mediterranean climate. San Diego, as you know, gets about 10 inches a year. We're about the driest part of the state. Do you know in our desert why we don't see saguaro cactuses growing? Anybody have a good idea? It's too dry. It's too dry. You see them in the Arizona desert because they get more rainfall and they get some summer rainfall. I mean, that's how dry our desert is. We're in a very dry climate. And then, of course, the maturity of the plant material. I told you about this ficus tree. It was about 70 feet tall and probably 90 feet wide. I never watered it. I mean, it got probably some supplemental water for some other things that I was irrigating, but it was probably a 75-year-old tree that had an extensive root system, probably got into a little bit of groundwater somewhere, and didn't need me to irrigate it to keep it green and growing.
Why did it fall over?
Why did it fall over? The sad part is I'm a certified arborist. And this is, yeah, exactly. You have it. That's why, because I was too busy doing other things to pay attention to my own garden. In fact, I'll sheepishly admit I've been in my house 8 years, and I finally landscaped the front of my house. My wife said, look, we're in our 50s now, it's time. So I am right in the middle. I've got the plants in and I'm just finishing the drip system, and yeah, it's a, you know, you get too busy doing other things. But on the tree, it had, I don't know how much you know about arboriculture, but there's different types of branch connections. And a really weak branch connection, like, so where the crotch of the tree is, this had a really weak, so that the more acute the angle, the weaker the connection. Well, I had basically a branch, the main trunk of the tree was just 2 branches. And what I should have done was put a bolt through the tree. I know it sounds kind of drastic, but there's really nothing else I could have done other than really whack at the tree, which I don't recommend. And if I would have done that, maybe a 3/4 or a 1-inch diameter bolt with some large washers, probably would have saved it. But the tree just went right down, split right down the middle. And there was rot. Because what happens is leaves and debris get in there and then it can rot. Insects get in there, create all kinds of problems. Okay, so we have the 6 main types of irrigation systems. Of course, the handy hose, which you're going to have people calling you up about. That's how they irrigate. The spray system, and what I mean by spray system, this is a fixed pattern head. That means when it comes up, it does its work, it doesn't rotate, it just is a fixed spray. Gear-driven rotor, so that's a broadcast irrigation where the head slowly rotates. So as you can see, this over here is not getting irrigated, but the area in front of the head, in front of the direction of the nozzle is. With a spray head, you're watering 100% of the area 100% of the time. Impact rotor, so commonly known as a rainbird head. Rainbird's actually a manufacturing company, but it's sort of like calling facial tissue Kleenex or Scott tissue. It's just gained the name. There's a wick system. How many have ever heard of a wick system? We got one. That's rare. Usually we have none. So that's a system my professor at Cal Poly actually invented. He's since long passed, but he was great inspiration to me, and he invented a pretty amazing system which we can talk about. And then of course drip system. A true drip system is not a mini sprinkler system. It's not a microjet. It's something that literally drips water into the ground. A lot of people call drip systems where you have a little riser and a little sprinkler head, but that's really a spray system. It can be a low precipitation type system, but it's not drip. So that's commonly what you're going to be up against. Yes.
How about weeper hoses?
That's a soaker hose. Yeah, that's true.
What about weeper hoses? Weeper hoses.
That would be, I would call that a drip system. The problem with those hoses is that generally it's going to put out more water near the hose bib and then less as it goes down the line. And with a good drip system, you have what we call a pressure compensating nozzle, or a pressure compensating emitter, which allows a variation in pressure, but it puts out the same amount of water at the beginning and at the end.
The gear just stays in the place that the rainbird goes like.
The gear slowly rotates.
But so does the rainbird.
Yeah, the rainbird. Good question. So what's the difference between a impact head and a gear-driven head? They have the same kind of purpose, that they slowly rotate and cover an area. Yes.
This is the actual water drive the rainbird. The water spraying.
Yeah, the way they're driven is slightly different. The water pressure drives both, but with the impact, the water pushes against the little lever that's on the head. Once the lever gets past the point of the spray, it comes back, slams against the head, and actually mechanically moves it. That's where the gear-driven head has a little gear drive in the bottom of the head, and the water passing past the gear drive before it comes out the nozzle slowly rotates. So the gear drive is much more of a scientific method of distributing water. The disadvantage of the impact head, why you don't generally see them very much anymore, is because to drive that head and push that lever to turn the head deflects water behind or to the side of the head, which usually puts water where you don't want it, or puts too much water right next to the head. Yes, I will do that. So does everybody understand that the difference between the two? A gear-driven head is more expensive, but it's a much more accurate way to get the water where you want it. just to give you an idea, they do efficiency tests on sprinkler systems, on irrigation systems. And an old system, let's say you have that with a little 3-inch pop-up champion head that they used to have, the little brass guys pop up about 1.5 inches. Let's say it's an old system and some of the heads are a little bent and not spraying properly. The efficiency could be as little as 20-25%, which means 75 to 80% of the water is not going where you want it to go. So when you calculate how much water that area needs, you have to put 4 times as much down to get it where you want it to go. It's sort of like driving your car with a leaky gas line. Other than the danger part of it, a lot of the gas is being consumed but not using to move the car forward. So it's the same idea. With a gear-driven rotor head is much more efficient. I mean, the more the water gets to the root zone of the plants than an impact head. And that's hopefully why you don't see people installing them anymore, although they're still sold and put in the ground. It's almost like going to the store and buying incandescent light bulbs. You can still buy them, but they're slowly phasing them out. Impact heads are still sold because people have 14 impact heads and one of them went bad. Well, the rotor companies got smart and actually make a replacement gear-driven rotor head that will put out the same amount of water as an impact head so that you can swap those out. So a drip system can be up to as much as 90% efficient. And that's why we highly recommend drip systems. Now you say, well, Steve, how come it's not 100%? Well, having something 100% efficient is going to be a really tough thing to do. I think if you could get it higher than 90, you could probably get it close to 100, but nobody's going to be able to generally design an irrigation system that's going to create that type of efficiency. So typically when we design for drip, if it's a well-done drip system, we're going to calculate 90% efficiency. Spray heads, commonly, even if it was just installed 50-60%, if it's done really well, maybe up to 70%, 75%. The problem with spray systems is, as you'll notice, when the heads pop up and spray, you get a little bit of misting. It's not going to give you an exact pattern, and water tends to go places where you don't want it. That's why drip systems are so much more efficient, because you're just dripping right at the root zone. Yes?
So what about for turf? Do you still recommend, I don't know if I've ever seen drip system for a lawn.
They do have drip systems for lawns, so you're asking about what about drip for turf. I don't have a lot of experience with it. We actually are maintaining a property right now that has a drip system for turf, and we're having a little bit of trouble with it. Yes?
How do you fertilize drip system? I mean, the turf, drip system.
How do you fertilize? You fertilize through a fertilizer injector system. The other way is to broadcast right before rain, or to water it in after you broadcast. Because as you know, when you fertilize with a pelletized fertilizer, you want to wash it off the leaves. You don't want that sitting on the leaves. So if it is a drip system for lawn, shrubs, trees, trees not such a problem, but for anything else, you want to make sure that you either fertilize right before a rainstorm or that you mechanically wash it off. So I want to make sure I answer the question. So on lawn systems, the wick system can be used for lawns. You can use drip system for lawns. The technology's been around for a while. I wish I could comment more about it. We're actually contemplating doing it on a property right now. The problem is the property that we're maintaining, we didn't install, and we're seeing some unevenness in watering. And typically what happens, my staff says, well, it doesn't work. And my opinion is, wait a minute, we're having trouble, it doesn't look good, but let's find out why. So what we're going to do is call the manufacturer, and then the manufacturer will come out at no charge, because they're very interested in their product. We don't buy from the manufacturer, we buy from the distributor. So the Hydroscape and Ewing and all these different distributors who buy from the manufacturer. So the manufacturer wants the end user to be happy with their product, so they're very likely to come out, make sure it's installed properly, that the irrigation system is programmed properly. They may find one of these things to be a problem, or maybe it just doesn't work. We don't know, but I will find out. Yes?
I have a question, I don't know if this is the right term for it.
The mantra I have heard from all the gardening organizations for a long time is drip, drip, drip. It's the best way to go. Some of us grow native plants, and when we go to our nurseries, Masculinda, Tree of Life, or organizations such as CNPS, the mantra there is overhead spray, overhead spray,
Has to be
overhead spray.
yeah.
So, I'm confused.
And you should be. You absolutely should be. And this is a great example of what do we do when somebody, the native folks tell us don't use drip on natives, and Steve says go ahead and use drip on natives. So you're going to get experts with different opinions, and this is going to be one of your challenges. Now, all I can back up with my story is I've been installing landscapes for over 30 years. I've been installing drip almost to the day that my first project I ever installed over 30 years ago is still there, and I can't say we had a lot of natives, but it's still there, it's still working, and even since then I've installed hundreds, probably thousands of gardens, and again, it's not a blanket statement. You can put drip on natives and kill natives. It's very possible. You can do it with spray too. And the main thing is overwater. But with drip, what I've learned works. The reason I say you can use drip on natives is I have a system that works really well. So one of the problems with establishing new plants is that you need to get water right on the root ball. If you don't irrigate right on top of the root ball until that plant gets roots into the native soil, you will lose that plant to drought. Why is that? Who can tell me? Why does, when you put a plant in the ground, and if you just water the area around it and you don't water directly on the root ball, anybody have an idea why the plant dies of drought? There's no water for the plant, but why is there no water for the plant? You're spraying water all over the place.
Difference in soil, native soil and what's
There you go.
not.
This is the key, the difference in the soil type. What's typically in a potting mix for a plant? How heavy is a potted plant versus one you dig out of the ground? Okay, so the potted plant is a mix, has a very light soil mix. And if you just learned about soils, the heavier the soil, the more clay in the soil, has more or less of an attraction for water than really light soil. Who remembers? Right. So the heavier soil has more of an attraction. So you take this sponge-like potting soil of a nice little 1 gallon plant, you put it in the ground, and then you have a clay loam soil or a medium soil. What happens is that soil will actually suck the water right out of the root ball. And that's why so many plants die when you first put them in the ground. I watered it every day, I did this, I did that. But I'll pull the plant out of the ground and the root ball is dry. And it's because of that action, that capillary action, draws the water right out. So that's why we have to have an emitter sitting right on the root ball. If you put an emitter into the native soil next to the plant, it could even be an inch away. It will not generally keep that plant alive. So the problem is having that emitter right on the root ball is natives don't like, and it's not just natives, drought-tolerant plants, most drought-tolerant plants don't like water right next to the stem. You can get basal rot. So what do? Well, what we figured out is we really are big proponents of drip. When you see this big difference in efficiency between spray and drip, is we put one emitter on a piece of microtubing. Familiar with microtubing? Little spaghetti tubing? I'm not a big fan of spaghetti tubing. The only time I use it is either for pots or for this situation. The rest of the emitters I put right on the main tubing, on the half-inch tube. So you have your tubing running around and you have it irrigating the area around the root ball, and then you have this one emitter that's staked right to the top of the root ball. And in 3 months, that's the magic number I've found, is in 3 months after that plant, you can see it's rooted and starting to grow, you take that emitter and you either put a goop plug in where the emitter was, or you just rotate the tubing around and staple it away from the root ball. That's how you grow plants successfully on the drip system, natives and drought-tolerant plants. And I don't know if anybody's familiar with Greg Rubin. I know him, he's a great guy. He's not the one who invented this idea that you can't water with natives with a drip system, but he is the Pied Piper for it. Every seminar I've ever seen him talk about irrigation, he's always telling people you can't water natives with a drip system. The other argument is it doesn't wash off the plants. Well, you know, you can always take a hose and wash off your plant if you feel your plant got dirty. But my feeling is we don't have a lot of water here in Southern California, and it's not a good excuse to have a spray system to wash off your plant. It's true, accumulation of dust will eventually slow down the sugar-making properties of plants. It's not going to be able to get the sunlight, but it's generally not something that hurts or kills plants. It may slow them down a little bit. So hopefully that answers your question about drip and native drought tolerant.
How long does the system last before it gets clogged? Because drip systems tend to get clogged. I mean, the clay kind of sucks back into the tube when the water's off or when it drains out or whatever. So they're a little problematic.
So the question is how long until the system's not going to work anymore? And in my practice, I've found that probably 90% of the time when I find problems with drip, it was the problem due to installation, incorrect installation. What was missing? First thing I see missing, no filter on the system. The drip system, the openings in the emitter are tiny, absolutely microscopic. And you've got to have a fine mesh filter in front of this system before it gets distributed through the drip system. Number two item that's commonly missing is the pressure regulator. Drip systems generally operate between 10 and 50 psi. And if your water pressure is too high, you're going to create problems. I've rarely ever seen clogging as a problem with drip systems if there's a proper filter and pressure regulator installed. Doesn't mean that it can't happen, but I'd say 90% of the problems will disappear. Again, it all has to do with proper installation. Using quality product, making sure that it's not some of the stuff that you find at the hardware store. A lot of the commercial manufacturers make a special product for the hardware store, and they put their name on it, but it's not the same quality as what the commercial vendor sells. So I think it's important to understand that. Yes.
I had a discussion with my local nursery about the capacity of the main line, and I've heard that the finite capacity of how many gallons per minute that a main line put out. His answer is we'll take the pressure regulator out and put, you'll have.
Yeah, it's like, and some of you may be old enough to know, it's like putting a penny in the fuse box, right? You're taking the safety device out so that you can crank it up. And it might work for a moment, but it's generally a really bad idea. So, but that gets into a whole nother theme of, I got this degree in irrigation and drainage science all about hydraulics and understanding pressure, and, I'm sure most of you would say if I had a 1-inch pipe or a 1/2-inch pipe and I put the same amount of water through it, let's say I try to fit 20 gallons a minute through a 1/2-inch pipe and 20 gallons a minute through a 1-inch pipe, most people would say at the end of the 1/2-inch pipe is going to be a higher pressure. And it's actually going to be a lot lower. If you're trying to push too much through, you lose pressure by having the velocity too high. You have another question?
Well, I was just following up. So you filtered your system. So is what we're saying the problem with the drip system is the filter needs to be cleaned? Is that the issue?
Well, that the filter's not there, or it's improperly sized. That the filter is not fine enough to protect the system that it's in front of.
Well, then it has to be maintained then, cleaned
Yeah,
up or
yeah,
whatever,
right. And it depends on your quality of water. Now, most of the water that we get here in San Diego is pretty clean water, but if you had a well system, kind of reminds me of a project I did about 20 years ago. I had a client who had a well. I was hired to put an irrigation system for this big property, a couple of acres, and I noticed that he had a well, but he had no filter for the well. Well, on a well, period, you have to have a filter, period. There's, don't let anybody talk you into not having a filter. When you're drilling in the ground and you're pulling water out of it, and he talked me into it because I was young and stupid and I needed to work. Well, what did I end up doing? I had to clean out all 23 zones. Every valve had to be taken apart and it was all full of sand. So it's the last system, we all learn by doing, right? And that was the last system I ever installed without a filter from the well. So the cleanliness of the water, You know, they make bug caps if you're having issues with insects that crawl into the outlet side of the emitter. I can't tell you in 30 years how I've seen that a dozen times maybe. It's a very rare thing. I usually don't plan ahead for things like that. It's just because it's so rare, and we're putting emitters in, not just one per plant. So if one of them did happen to get clogged after a number of years, generally after our plant matures, it's not going to be that big of a deal anyway. And you can always add an emitter or replace that emitter. Okay. So, efficiency. I talked a little bit about irrigation efficiency. So I was talking about the efficiency of a spray system is typically, if it's done really well, maybe 70%. That's when it's brand new. That's if it was installed properly. So what are the common things that you can check on or do to increase the efficiency? So replace and adjusting the nozzles. The first thing I recommend you do is when you have an irrigation system, let's say it's a spray system, you turn the valve on and you inspect it. A couple things that I want you to do. You should have a stopwatch with you, or your iPhone, or whatever you're carrying around. And as soon as you turn on the valve, one of the things I want you to look at is how long does it take before the heads pop up? So you know, some systems, you open that valve and man, it's instantaneous. That generally means your water pressure is probably a little too high. Other systems, it takes about 2 or 3 minutes before everything really finally gets up and is able to push those springs and push those heads all the way up. That generally means that you've got a low pressure problem. And that low pressure problem is often caused by under-design of the system, where somebody's put too many heads, where we get now into gallons per minute and available water pressure and size of main line. We could spend all day on just irrigation design. So knowing how do you adjust the nozzle? Well, a lot of nozzles have a little center screw, and the manufacturers will tell you right on their website that that screw is only for adjustment of about 5 to maybe 15% of the normal throw of that head. If you're having to crank down on a nozzle because it's spraying 15 and you want it to spray 9 or 10, you have the wrong nozzle. You'll notice on a lot of manufacturers' nozzles, there's a number on the nozzle, and the number generally designates how far it should be from the next head and from where you're trying to spray. So very commonly, landscapers it's what they got on the truck. I mean, believe me, I come from an industry where the reputation is not extremely high. And we're working on that. But that's the common thing. I go to the supply store, I buy 100 different 15-foot nozzles, and I make them work. I put that fuse or that penny in the fuse box. So really what you're looking for is, when I do an irrigation system to analyze one, first thing I do is I look how far is that head supposed to throw, and then I'll look at what the nozzle is. And once in a while it's right, but most often 15 is the most common size nozzle, so that's the one I see everywhere. Even in an 8-foot space or a 12-foot space, you see a 15-foot nozzle. So if you find that the case, then you have to put in the proper nozzle. The other thing that you'll find is you'll turn on a system, and there's an impact head on one outlet, and then another outlet there's a gear-driven head, and maybe in another outlet there's a spray head. I didn't even see drip systems connected to spray systems. What's the problem with that? Anybody have a thought? Pressures requirements are different, but the actual, what we call precipitation rate, the best way I can describe precipitation rate is, let's say, not to say what happens, but let's say we get a little misting coming down, okay, versus a downpour. Okay, both setups, there's moisture, there's a precipitation rate, but misting or sprinkling is a very low precipitation rate, and a downpour is very high precipitation rate. Well, spray heads have high precipitation rates, and drip systems have about the lowest precipitation rate. And then gear-driven heads generally put out about 1/3 the water of the spray head. So if you've got a gear-driven rotor and a spray head on the same line, then you're going to have a really wet spot and or a really dry spot. And so you got to make sure that they're matched precipitation rate heads. And generally that means they got to be the same type. You can't have a rotor and a spray on the same valve. It's impossible, because a spray head puts out 3 to 4 times the amount of water. Yes.
You mentioned that they make replacements for the impact. Can I change my spray heads to rotors? I mean, is the pipe size big enough for that?
Good question. It depends. So you'll notice in the photograph here, if you can see it, there's what we call an MT rotator head. This is the way to change a spray head into a rotor head without even changing the body. You just change the nozzle. So because rotor heads have a lower precipitation rate, it's usually easy to convert a spray head to a rotor head because you're going to put out less water. Now, what do you have to do if you're putting out less water? You've got to increase longer. So you have to make adjustments. Now, if you wanted to go from a rotor head to a spray system, that's probably not as likely because the spray head has much more of a demand for water. It works at a lower pressure, but it takes more volume. So it's really important to have this understanding that you got water pressure, so that's the potential for water to be pushed down the pipe. And then you've got the flow. That's how much the pipe can handle. So if you have a system where it has high demand, a lot of flow need, you need a lot of flow, you have a bunch of sprinkler heads, the pipe has to be big enough. If the pipe's not big enough, when you squeeze that size, so it means the water has to go faster through the pipe, and when it goes faster through the pipe, it rubs tighter against the outside of the pipe, and then you lose water pressure. So that's why if you have both, a great way to show you is like a garden hose. If you have a half-inch garden hose that's 100 feet long, probably not going to be able to find it. You'll notice that the longer the garden hose, the bigger the diameter of the garden hose. And that's because the engineers have figured out that to be able to put the same amount of water through, you've got a longer distance takes a larger diameter. Because the farther that water has to travel through that hose, the less pressure is going to be at the end because it's using up pressure to push that water against the sides of the hose. Again, I don't want to get too much into hydraulics, but those are the basics. I'm trying to do it to where hopefully you folks are picking it up. I've had people in the landscape industry for 20 years do not get this. They feel that there's going to be higher pressure on a smaller diameter hose. And what are they thinking? Well, I put a cone nozzle and it shoots farther. And it does shoot farther, but the actual water and pressure that you have at the end of that hose, if you were to put a gauge on it, would be a lot lower than a larger diameter. Okay, is that everybody kind of getting that? That it's the friction. That's what's using up the water pressure. It's friction. Here's a great example. Once I had a client who called me up and said he's got no water pressure. It's very low. I go to his house, I have a pressure gauge I keep with me, I screw it onto his hose bib and I turn it on, 130 PSI. That is not low, okay? But he just told me he has no water pressure. So what do? I take off the pressure gauge, I turn the hose on, and sure enough, barely any water comes out of the hose. How is that possible? How can I have 130 PSI and then open this thing wide open and water is barely coming out?
There's 3 or 4 half-inch hoses put together, it's like at 300 feet or something on the half-inch hose.
That's a possibility, except I'm hooking right to the hose bib. I'm right where it comes out of the ground. So I don't even have a hose on it. I just have the valve. I'm turning the valve open, and barely any water is coming out. Okay, so the only reason I was able to figure this out is because I had this hydraulics class at Cal Poly. And right away in my brain, it says, yeah, my pressure gauge isn't broken. I do have 130 PSI. But right away, what it told me is somewhere between where I'm checking and the city water main, the pipe there's either a valve that's almost all the way closed, or there's a rock or a crushed pipe or something. Because as you can imagine, water pressure is only a measure of the potential for water to flow through the pipe. And not much has to flow through to move my gauge to a pressure. But as soon as I create what I call a demand, where now I want 20 gallons a minute, well, that restriction is not allowing the water to come out. And what's an easy way to test it? As soon as I crack that hose bib open, the water squirts out kind of fast, and then as soon as I open it up, then it just barely pours out. So imagine that. So what I do, I start digging up the main line, and sure, I find a root that has crushed this half-inch copper or 3/4 copper main line to where there's barely any water that can get through. So that's a good example of having high water pressure but no flow. Okay? Does that everybody understand that? So you could have a pinhole opening in that 3/4 pipe which will read 130 psi. It's when I create demand. So when I say now I want a gallon a minute, or I want 5 gallons a minute, well, that pinhole doesn't allow enough water to push through the pipe. So then the pressure drops dramatically. So that's like having a really long hose. A 1/2-inch hose that's a mile long, you probably have the same problem. I had to find that crushed pipe and then replace it with a non-crushed pipe, and then everything was fine. He thought I was a genius. That's what I did. I helped him think I was a genius. But it's only just understanding the physics behind it. He explained it very clearly. Okay, so aligning heads. What I mean by aligned heads is if a head is not perpendicular to the area that it's watering, it's not going to throw the water out evenly. So how many people have seen a slope? You got a slope like this, and the head is like this. That is not perpendicular, right? Perpendicular is like that. So whenever you're irrigating on a slope with a spray system, the head should be, if the slope's like this, the head needs to be perpendicular. If you do this, the head's designed to broadcast perpendicular pattern. So make sure if it's in a lawn, then when the head pops up, if it's at an angle, it's going to throw a lot of water down one side and throw it up in the air high on another side. And that's going to create inefficient irrigation. So that'll help. Checking the type spacing and location. Generally with spray heads, you don't want the head right at the edge of where it's supposed to cover, especially on a slope. You'll notice, hopefully on most new installations, the bottom row of the spray heads is not at the bottom of the slope. And why is that? Why would you have the head a foot or two above the bottom of the slope? Because of gravity, right? You irrigate long enough, water is going to run behind the head. So why water here where it goes onto the sidewalk immediately doesn't soak into anything? You always want to be a little bit above the bottom of the slope. But even in a lawn, you don't want that head right up against the lawn edging or a sidewalk. You want to have it about an inch, inch and a half at least. Because again, you got a spray pattern where some of it's going to go a little bit behind the head. And we're trying to minimize runoff. We even do it sometimes if we're putting in a lawn, which we rarely do anymore, but if we put in a lawn, we'll back it off maybe a foot. And well, if you do a foot, then you have to irrigate there. We'll lay a drip tubing along the edges, if it's sidewalk or whatever, and it'll irrigate that last few inches and keep it watered. And that minimizes overspray on the patios, sidewalks, houses, all of that. Upgrade the controller. So if you have an irrigation controller from the 1950s, it still is mechanical, actually has little motors that turn the wheels. Time to chuck that thing, put it up on the wall in the museum. We have controllers nowadays that are fairly inexpensive and have what we call multiple programs and multiple start times. Why do we need multiple programs and multiple start times? Anybody have an idea? Yes.
Sometimes you have different needs.
Different needs, exactly right. Plants have different needs. And that's another way to really conserve water is that I have 4 avocado trees. What do avocado trees like? Why they love water. If you have that connected to the rest of your fruit trees, what are you doing? You're either underwatering your avocado trees or you're overwatering your other trees. So I have a zone just for my avocado trees. Now, if I'm putting in a landscape and my client has 2 avocado trees, you should always plant at least 2 because they need to pollinate, cross-pollinate. That's not many trees for one zone. So if I have a lawn, and it maybe sound a little weird, but if I have a lawn or a vegetable garden, I'll tie those onto the same zone because they have about the same water requirement. Even pots. All the pots, the problem with pots is you're only watering for a short time, so that really doesn't work very well. But you got to match things up. So having an irrigation controller that can water something every day or twice a day. If you have hanging baskets out here, if they had a bunch of hanging baskets out here in the summer, how often would they need to water? Yeah, if they're not succulents, if they're petunias or marigolds or impatiens, yeah, probably at least twice a day, maybe 3 times. just for a minute or two, but 3 times. Well, you need to be able to do that and then water your citrus once every 3 weeks or once a month, or maybe your drought tolerant plants not at all during the summer, or maybe once every 10 days. And then your lawn every 3 or 4 days. So you have all of these different frequencies of irrigation. You need a controller that can handle that, because if you don't, then that causes, usually you got to water the thirstiest plant on your zone. You got to water to that, and that's going to overall use more water. And like I said, the new controller is very sophisticated. The pricing isn't too bad. You can even get them that have weather stations, or will adjust based on the time of year. Yes.
How many zones can you have on one of those?
How many zones can you have on one of what?
Controller.
Okay, so zones are the areas that you want to water. So you have lawn is one zone, trees is another, shrubs in the sun, shrubs in the shade, vegetable garden. There are controllers that can water 48 zones or more. We even have properties now we maintain from our computer. Our computer connects to their irrigation controller. We can actually make adjustments from our iPhone or from the office. All the way down to the smallest is like I think I've ever seen is a 4-station control. So 4 zones, stations and zones are the same term. 4 zones up to 48 is common. So, and the other thing I recommend is one controller. I see some big properties that have 4, maybe 5 irrigation controllers, because what was available at the hardware store? Only up to 6 stations or 10 stations, so that they would buy, even though they could have done it with one controller. They have, and what do they have to be careful of? Not overlapping start times and water pressure. To me, it's a disaster to have more than one irrigation time. Yes.
I have a system, and I have my front lawn is I rent, so I wouldn't have lawn if it was my house. I have the lawn on the front, but it's also attached to one in the backyard that I've converted to water my vegetable bed. If I wanted to take that off of the lawn, how can you change once the stations are already set up like that? How can I change? Do I have to go whatever that? I forget what the name.
The valve?
The valve. Do I have to go back to the valve and change the wiring in order to do that?
Well, if you turn on that valve and both the front lawn comes on and the backyard, that means that valve is servicing both. You have to find out where the pipe runs to the backyard, cut that pipe and put another valve, an additional valve, and just water that separately. That's what you have to do. Well, you just run a wire. You just got to run a wire to that valve. Hopefully your controller is big enough. Rain sensor, yes.
Totally the controls. I think it was in 2012 when you were talking to us, you said you could save the state half the water that's being used if you just add people irrigation on their control.
Yeah, boy, that's great. You were there and then you remember.
I remember that quite well.
I'm telling you, water management, I haven't changed my tune. Water management is the key. Controllers, fancy sprinklers, moisture sensors, rain sensors, they're all wonderful tools and they'll all help us save. But nothing is in comparison to the person that's actually punching the clock. That's where you save the money. It's sort of like you could have a super high mileage car, but if you drive it like an idiot, you're going to get bad gas mileage. And most people don't use what the start times. So what are start times? That's when you choose to irrigate and how many times you choose to irrigate a certain area during the night. And this is a great topic because I was going with this. Why do you need the stopwatch? When you turn that zone on, start the stopwatch and then look how much time it takes before water starts to run off. What I mean run off means it's not ending up where it's supposed to go. And generally you'll find with a spray system, it's going to happen within 2, 3, maybe 4 minutes. And most people's spray systems are programmed for 10, 15 minutes, which means after 3 or 4 minutes, all that rest of that water is going to get completely wasted. You may not see that it's getting wasted because it may be running down a drain that's in the lawn, or it may be running off under shrubs and ground cover where you don't see it. But they've done studies with a spray system. Now this is, again, one of the highest precipitation rate systems you can put in, and it's the most common, is that if you have sandy soil on level ground, you can water for 5 minutes. After that, the soil gets to what we call, do they talk about field capacity? Okay, great. You guys are great listeners. So, what's field capacity? The best description of field capacity is if you take a sponge and you put it under the kitchen faucet and you slowly let water into it. And the sponge swells up, and then you keep running water into it, what eventually happens? Water starts dripping out of the sponge. That's field capacity. That means the soil cannot hold any more water. It's going to start going below the root zone. Is there a reason, or if you turn the water up, let's say really fast, what happens? Water starts running off the top of the sponge. Well, that's generally what happens in our irrigation systems, is we're applying more water than the soil can take, so it runs off the surface and then it starts going places you don't want it to go. So that's what the multiple start times are for. A good controller has at least 3, hopefully 4 or more start times. I have controllers we install have 8 start times. And if you have heavy clay soil, let's say the worst conditions, compacted, heavy clay soil on a slope with a spray system, you can water for about a minute, and then after that it starts running off. So that's where you would need the 8 start times. Of course, if you have those conditions, don't use a spray system to irrigate that slope. Okay, so does that make sense? Sandy soil, level ground, 5 minutes. Now let's say you need 15 minutes worth of water. What are you growing?
So when I freeze, it'll be much longer.
Right. But you can't water for more than 5 minutes at a time. That's what the start times are for. It allows you to water for 5 minutes at midnight, 2 o'clock in the morning, water for another 5 minutes, 4 o'clock in the morning, water for another 5 minutes. What we have is time, right? We all have a certain amount of time anyway. What we don't have is soil that can take the water very quickly. Yes.
That was going to be my question. Is there generally a certain recommended period of time between the end of the first watering and the second? That's like 2 hours?
Yeah, I say 2 hours just because if you have heavy clay soil, it's going to be the slowest infiltration rate. If you have sandy soil, you could do it probably every half hour. But if you just want a general amount of time, you should irrigate, in my opinion, between midnight and 7 o'clock in the morning. That's when you should be irrigating. Drip, it doesn't really matter when you irrigate. You can irrigate any time, but for broadcast irrigation systems, that's the key time to irrigate. Yes?
What might it mean when the water system goes on, my house shakes? Or, you know,
You got a very excited house. What that means is, I would guess, now usually it's going to shake, that means there's what that's called is water hammer. Okay, so that's a phenomenon that happens when the velocity is very high. When you're trying to make the water start and move down a pipe faster than it should be, or you're trying to shut it off too quickly. Usually you'll find more of that when the valve shuts off. Because if you can imagine, let's say you've got a 100-foot main line, you've got a 1-inch pipe, and you've got water traveling at 30 miles an hour. When the valve shuts off, it just closes. That means all that energy that was moving, that dynamic energy, all of a sudden doesn't have any place to go. So guess what it does? It hits that valve and then bounces back and forth, and that's what you're hearing. So when I hear that sound, that tells me that either the valve is shutting off too quickly, or more likely your water pressure is it's too high.
usually it means it's time for me
Or
to
you got
wake up.
or you got a really loose pipe, and I actually have that at my house. It's a real loud ding, or it's not very loud. But all I know is I just need to get a strap and tighten it up a little bit. The pipe is just hitting a stud. It's barely moving, but it reverberates through the wall. So that could be it too. It's just a loose pipe.
Can you adjust the valve at the city main, can you adjust it there so that less water is coming through or decrease the pressure
Okay,
at
so
that point before it's coming on?
The question is can you adjust the valve at the point of connection from the city? Now, the question would be is what are you trying to accomplish? Like, you're trying to lower her water pressure? Well, remember the story I told you about the pressure gauge. It was a pinhole and they had too high a pressure. So that's not going to fix it. What will fix it is a pressure regulator. And what that does is it's a valve that automatically adjusts to allow, let's say you want 60 psi. 60 is a good number for houses. Your house water pressure inside should be no more than 60 pounds. Once I had a client, and I'm doing the irrigation system, and he has anti-siphon valves, and I don't like more than 70 psi before the valve. He's got 110, and so I noticed that he also has no regulator for the house. So that means there's 110. I just told you 60 is about as high as you want for inside house. So I asked him a question. I said, "Hey, how are your showers?" He says, "Oh man, they're amazing." Okay. And then I said, "When you use the bathroom, do you flush the toilet?" And he says, "Oh, don't go in there." He says, I can't sleep during the night. Somebody uses the restroom, and when that toilet fills up, it starts screaming. So I put this regulator in. I was his best friend for life. He says, I haven't had a good night's sleep in years. He didn't know that it was only because his water pressure was high. So the valve in the toilet's trying to shut off against 110 when it's designed for 60. So the best thing is this regulator can take a variable amount of pressure in front of it and have a constant behind it. So it has a spring in it that it adjusts automatically. Yes?
What would you suggest for fruit trees, both in the ground and in pots, like a circular drip on tubing on the drip line, or spray? Not avocados.
Like citrus trees?
Yeah.
If I'm planting them young, I always plant them on a drip system. You know, trunks of trees don't like to get wet typically. And that's perfect for a drip system because you're not spraying the trunk. If you do put a spray system in for trees, put the head, a foot or two away from the trunk and spray away. The tree will be much happier, less disease problems.
So what about time-wise? I mean, I'm sure that depends on the size of the tree, but generally speaking.
Well, what we'll talk about more in here is, depending on the system you have, what you want to do is you want to water to the rooted depth. Okay, so if it's a young tree and you put a 5-gallon in, that means you want to water about a foot down. You don't want to water 3 feet down, it's a waste. If you have a mature citrus tree, which mature citrus trees, most of the roots are going to be within the first foot of soil. You'll have probably 20% maybe in the second foot, not much below that. So let's say your goal is you want to water 18 inches or 2 feet down. So what you want to do is irrigate. I don't know if you have moisture sensors, you're familiar with moisture sensors. That's the best way. It saves a lot of digging time. If you have a good moisture sensor, I have one that's 3 feet long, so I can push it down and see how wet it is at the top 6 inches of soil, how wet is it at a foot, 18 inches to all the way up to 3 feet deep. And that's the best way to really know how your system's working. When you water for 15 minutes on your lawn or for your fruit trees, how deep does the water actually go? Now there are calculations you can kind of estimate, but this is the real thing. This is saying, okay, I irrigated last night, I'm going to go out the next day and I'm going to probe the soil and I'm going to see where did I get down to. And then you can determine how many start times and the run time of your clock. Now we talked specifically about spray systems, and the reason I talk about those is just because they're the most common and they're the most easy to waste water because they have such a high precipitation rate. Rotor heads, like I said, you can run rotor heads for 3 times as long and put out the same amount of water. So automatically, then a rotor system can easily be on for 15 minutes or more depending on the precipitation rate. And of course, a drip system, you can run it all day long. It's not going to run off. It's just going to go deeper and deeper and deeper. And the wetted pattern in a drip system is going to vary based on soil type. So if it's sandy soil, it's going to be more of a columnar section. If it's clay, you'd be amazed. We can put emitters 4 or 5 feet apart and it'll water the whole area if you leave it all alone, because it pulls laterally through the soil. Okay? So, quick upgrades, better controller, rain sensors, great little inexpensive, $50 or so, which would just interrupt the irrigation system during the rain. You can set them to where it stays, after a couple of days it'll come back on. They're adjustable, most of them. Soil moisture sensors, not as commonly used, but they actually are reading what the roots read, which means it's more effective. The only problem with soil moisture sensors is if you don't have the same type of soil everywhere, then you're going to have multiple moisture sensors. If you have a very even soil, live in an older area where they didn't scrape all the topsoil away, then you might, soil moisture sensor would be a good move. And of course you want it in the place where it's going to get driest first. Because what you do is this actually interrupts the circuit, so it won't allow the controller to come on. Really the perfect irrigation system is a drip system with a soil moisture sensor. You don't even have a timer. It just irrigates when it gets dry, and it doesn't irrigate if it's not dry, period. And the reason I say for drip is perfect, because if it comes on at 2 o'clock in the afternoon when you're out in your yard, it doesn't matter, you're not going to get wet, it's a drip system. But most of the time they are connected to an irrigation controller, and it just interrupts the circuit, and it just doesn't allow the controller to water. Of course, locating and repairing leaks, really important. Yes?
I remember seeing a subscription-based type of a controller. When you talk like those sensors, I have no idea how to get the wire under my slab or under the sidewalk to get where the controller is.
Yeah.
These other ones, I think I thought they were expensive because you have to have a subscription to some kind of a
Weather station.
weather station.
Yeah, there are controllers that you can pay a monthly fee, and it connects to a SIM station, which is these stations throughout the state that actually monitor what's going on right now. And they'll tell your controller when and when not to irrigate. Pretty sophisticated, but when you start looking at your water bill, you may be able to justify, I think they're like 20 or 30 bucks a month for the communication. Not cheap, but if your water bill's 500 bucks a month and it saves you $100 or $200, it's well worth it. Yes.
Okay, we have all of that. Brand new, it's about a month. Nothing dries out. We have sandy loam, and we have hard pan about 25 inches down, and we have a 0.6, and it's every 12 inches. The emitters are every 12 inches, and we're down to 10 minutes, once every 10 days, and when I use the hydrometer, it still tells me soaking wet.
Okay. Simple solution. More than every 10 days. Water less than every 10 days.
Brand new plants.
Brand new plants. And the plants are fine.
Seem to be, but you and I know I'm not gonna, if
Yeah.
there's a problem, I'm not going to know it until it's too late.
Well, hopefully you're talking to your plants and you see that one of them will take a little bit. I installed a brand new garden, and I'm not used to watering this time of year. And of course we finally had a rain, but before that I had to go out and turn the water on because these new plants were starting to wilt. But I watched them every day. When they start talking to me, I give them some water. And it was funny, not all of them, but certain ones you can see which ones were stressed and which ones were fine. And now next year, this won't be an issue, but this year it is because they just have that little root ball. They haven't grown into the native soil yet. So yeah, every garden's different, and I can save more water at my house than any of my clients' farms because I'm there every day and I see it. And I've had literally 6 months, 7 months in most years I don't water at all. Zero. And my clients think if I don't water every day, everything's going to die at their places because they're just so used to it. So we're going to have a break now, and appreciate all the questions. It's been very helpful.
What do you mean by hydrozoans though? Do you mean hydrozones or zones? Is that?
Zones. Hydrozones. Yeah. Sorry.
I
about
thought
that.
maybe it was biological.
No. Horticulture was my passion.
How difficult to replace the hand-operated valve to that electronically operated valve?
How do you change it?
Yeah.
So how do you modify a manual valve to an automatic valve? They make an actuator that you can take the manual device out of most valves and you can put in a replacement automatic actuator. So you don't even have to cut any pipe on most valves. You can just exchange the mechanical mechanism for an automatic one. And then you need a controller and wire and timer. We can get more into that when we get back.